Good morning. We are diving into the second part of kind of our work with law of sines, law of cosines, which is 5.6 according to our textbook. Law of cosines. Okay. So law of cosines, what is the difference between SAS and SSA? And that kind of fits yesterday with our conversation. What's the difference between ASA and AAS? Because that helps us recognize kind of what's going on. So law of cosines looks like this. Law of cosines. It's a long one, fam. Here we go. C squared equals A squared plus B squared. That's not the law of cosines. That's the Pythagorean theorem, which is fun. Okay. Minus 2AB cosine C. Now, I could write it a different way. A squared equals B squared plus C squared minus 2BC cosine A. Or B squared equals A squared plus C squared minus 2AC cosine B. Okay? So what you hopefully are seeing here, what my hope is for you is that you notice that B squared matches up with angle B. So yesterday we talked about the importance of side angle pairs. Right? We used the story of Goldilocks. And we said that those side angle pairs were so important because the piece of the puzzle that we care so much about is that we're working with that together, right? That every angle matches up with the side across from it, just like the bear matches up with the porridge. Anyway, example. In our example, let's look at this. So we've got a triangle DEF, and angle D equals 410. Angle E equals 300. And angle F, well, side E equals 300, my bad. And angle F is 126. Okay? Find the length of everything else. Okay? So this is a case of SAS because we've got two sides and the angle between them. We have three different letters. Okay? And so what we're going to do is we're going to work with this angle, which is going to help us determine how we're going to set up our law of cosines. What I mean by that is since I know angle F and I care about the side angle pair, I'm going to go F squared equals D squared plus E squared minus 2DE cosine F. I don't know what F squared is. I don't know what F is. Little f. I don't know what the measure of little f is. 410 squared plus 300 squared minus 2D E cosine 126. Okay, now this is pretty cool. I can potentially put all of this into my calculator at once, right? Because what's happening here is I don't have any variables on that side. So here we go. I'm going to go to my calculator. I'm going to say, calculator, do this. 410 squared plus 300 squared minus 2 times 410 times 300 times cosine 126. And if your calculator is like mine, and hopefully we're moving and grooving, we got 402,695.17. Now, calculators are cool because they store all that information. I finished by taking the square root of that, and I figure out that F is 634.58. Okay? So that 634.58 works because that is officially the longest side across from the longest angle. Now we have a complete side angle pair. So we're going to continue with the law of sines because now we know angle F and we know side F. So sine 126 over 634.58 equals sine D over 410. 410 times sine 126, close your parentheses, divided by 634.58 equals, so sine D, right, cross multiply and divide, equals 0.5227. And I'm going to take sine inverse of that answer, second sine inverse of that answer, and I'm going to get that D, and I'm going to make it a whole number angle. D equals, well, it's 31.5. Just kidding. I'm just going to leave it with a decimal. And then once I have two angles, I can lock it up by using 180. 180 minus 126 minus 31.5. And I get 22.5. Which makes sense because that would be angle E, and side E is the smallest. So it's kind of a process. I want to show you one more example. And in this example, we won't work through the whole thing, but I just want to show you kind of, I want to start the conversation on side, because that was side, angle, side. So let's look at one that's side, side, side. I'm going to show you kind of a Visto pro tip to make your life a little bit easier when you do side, side, side. Law of cosines is great for helping us decide if we have a obtuse angle or not. Okay, and what I mean by that is the whole point of the law of cosines is it works really well because cosine has inverses from 0 to 180. Sine gets a little bit wonky, and so what I want you to do is when you're trying to work with law of cosines to start things off, and you're not sure, like if you don't have an angle, you have three sides, center your work around the biggest side, because the biggest side, if there's an obtuse angle, it will happen attached to the biggest side. So I'm going to use a squared as my side equals b squared plus c squared minus 2bc cosine a. So I'm going to plug everything in. 9 squared, 7 squared plus 5 squared minus 2bc cosine a. Cool. Order of operations is going to be super important here. This 275 cosine a is all attached together, which is great. We cannot break that apart. We have to deal with them together. So here's what we're going to do. We're going to deal with all our squareds. Square everything. And then I'm going to just focus on, I'm going to keep cosine a in the picture, but I'm going to focus on this 2 times 7 times 5 and get minus 70 cosine a. So I'm just taking it one bite at a time. Then that 70 is attached to cosine. I cannot state that enough. So since 70 is attached to cosine, I am not touching the 70. I'm just touching the 49 and the 25. And over here I have negative 70 cosine A. Okay. Divide both sides by negative 70. Get negative 0.1 cosine A. And then again, just like before, I want to get rid of a cosine, just like I want to get rid of sine up above. So I do the inverse. And I get about 96 degrees. So I want you to remember, so I guess let me write this in blue. Start with the longest side. It will make your life easier, and this will help you identify any obtuse angles. We could continue with law of sines and go from there, but it's been about 10 minutes and I appreciate your time today. I'm posting a Delta Math as well, but remember, we're going to have a great work day